In the case of blockchain-enabled systems, we really don't need to think about blockchain at all, per se. What we really need is to fill in the layers. And so, this is going to ask the same sort of questions, where we start at the ecosystem level, flows, the roles in the system, the stakeholders, how value flows between them structurally. And we can ask what kinds of pairwise or lower level micro interactions are required to have that make sense. And we can then sort of say, okay, well, now that I know what my protocols are going to be at the interaction pattern level, like what I need to do to engage with you, then if I want to do this without a centralized governing body or a platform, then I need something else to do the validation of my rules of physics equivalent, right? So we do this with a peer-to-peer network. It's a decentralized computation and communication network. So we're just basically sharing messages with cryptography and saying, well, whatever it is that I need to say to ensure that the system above actually is trusted in a computation sense. And in fact, that communication and computation network relies on software. And so someone has to create that software. It defines the rules of what it means to participate in the peer-to-peer network. And what's interesting about this is that while it's mixtures of sort of networks of sort of communities, like entities participating with each other, and then software that allows something, it's not community, community, software, software. It's community, software, community, software. It's mixed. It's a layer cake. We've gone from what was that we imagine the evolution or ecology of the community, and then the software that allows those behaviors, then the community that enforces the correct use of the software at the level above, and then sort of the lowest level of software, which is just creating the rules for that coordination, for that communication. So there's two distinct layers of coordination problem actually appearing here, and we actually have to separate them if we want to get them right, because one creates the physics and the other creates things under physics. And the way that we sort of think about the two layers in the technological sense is when we're doing interaction patterns, the rules about how we engage with each other, we can think about things in terms of those conservation laws. And so I have an example here. It's a little bit abstracted, but it basically imagines that a good is going to be exchanged for a service, but that there are some positive and negative externalities exposed by this. It might be pollution generation, and then on the flip side, there might be some positive social impacts because you're helping your friends. And you have both a positive and negative externality, which in a traditional sort of just pricing market model would be completely lost. It's missing from the structure of the problem. The impact occurs anyway, but if it's not actually accounted for in the action that is taken in the price, then it won't be reflected in the behavior, and therefore the system will literally not account for it. People will sort of optimize on their local objectives, and this constraint is missing, and we lead to things like large amounts of pollution or sort of adverse effects on systems simply caused by missing structure. The underlying natural system has a structure. There's a real dependency, but the financial or economic system that you're leveraging, the pay for service, ignores a structural element. And we actually see a lot of our systemic breakdowns in our current society can come from parts of the system that we know intuitively or even scientifically are there, and our economic system ignores them, maybe because we don't have the tools or the means to account for them properly. But nonetheless, that structural misalignment makes it so that the optimization that's achieved by the sort of economic behavior actually drives the system into an undesirable state rather than into a desirable one. And it's my hope that we can address that through sort of cryptographically empowered technologies. I don't generally jump to blockchain because blockchain is we've talked about its hype. It's a great example. It sort of was a proving ground for this idea of durable state and verifiable computation. But at the lowest level, what we really need is trustworthy data. If we know that the data that we have represents, we won't even say truth because it could capture subjective data, and it's meaningful to have subjective data because you can have various interpretations. But we know that it's history. We know its provenance. It was logged at this time. If I go to get it later, I know that it's the thing that I thought it was. And we do this through content addressable DHTs. We can do this through DAG structures, not necessarily in the blockchain DAG sense, but a directed acyclic graph just means that there's sort of this ordered reference where you know that something came before something else, and you can know this cryptographically as long as you have a reference, because you can't reference a thing with its hash if it didn't exist when you wanted to reference it. And so you get this sort of attribution, and you can even add in attestation, meaning that someone might reference a thing with a yes, this is true, or a no, this is false. And you don't actually have to even a priori decide how to interpret that. So we have some pretty powerful tools from a data structure and trust perspective. We really are just figuring out how to use them. And actually, one of the things that I'm most excited about is what it means to get these sort of flexible but provable, sort of not pre-interpreted, lowest levels of data into place, and then we can build up on top of them. And things like blockchains are great for holding information that everyone needs to know. So they might even hold the rules about how to use a system that's a little bit more general, because as a redundant database, you almost only want it to hold the things that everybody needs to know, because otherwise you're wasting energy, it's not an efficient use of the resource. So I think the tools are really exciting. I think new tools are coming, and I think that we should really look at them in terms of the systemic structures. That's why we come at this from a complex systems perspective. We kind of know what we need, and we use what we have, and we also can push forward to find the new things that we need to fill in those roles in the stack better.